Hi students. So in previous class we discussed about the geometrical meaning of the zeros of a linear polynomial. Okay, so in linear polynomial we plot a graph also. In graph that linear polynomial in straight line. Okay, so today our topic is geometrical meaning of the quadratic polynomial. Okay students. Geometrical meaning of zeros of a quadratic polynomial. So already I told about what is quadratic polynomial. What is the format of the quadratic polynomial? What is the format? Y equal to ax square plus bx plus c. This is quadratic polynomial. Why? Because here the highest degree is 2. So this is our quadratic polynomial. So how we represent this one? By geometrically. Okay? By graphically. In previous class we plot the graph of linear polynomial. Okay. So today quadratic polynomial. Okay, so how we represent this quadratic polynomial? By graphically. So first, in linear polynomials the shape is in straight line, but here in quadratic polynomial the shape is in parabola. What is the shape? Parabola. Okay, one of the two shape means what? Here one is open upward parabola and another one is open downwards parabola. Okay students, so in quadratic polynomial the shape is parabola. One is open upwards parabola, another one is open downwards parabola. Okay, the shape open upwards means like this. Okay, and this one downwards parabola means like this. Okay students, open, see here the parabola is open, here also upward means upwards and down means downwards. Okay, so this is our parabola shape. When we represent this quadratic polynomial in graphically, in that time the shape is either open upward parabolas or open downward parabolas. Okay, that shape is either open upwards parabola or either open downwards parabola. Okay student, so now here three cases is arises when we plot the graph. So what is that case? Case 1. First one is case 1. What is case 1? So when we represent linear polynomial, in that time one thing is important. I have told that. What is that one point? That point is when how we know that one is zeros of that linear polynomial when the point intersects the x-axis. Okay, so here same thing. Okay, so here also same thing in quadratic polynomial. If the points intersect the x-axis, that time that one is our zeros of this quadratic polynomial. But one thing is here different. Here 2 points intersect the x-axis because this one is quadratic polynomial. Here the highest degree is 2, so that here 2 point is intersect the x-axis. So our case 1. See, this one is x-axis, this one is y-axis. Okay. So when we plot the graph, here see. This one is open downwards parabola, this one is open upwards parabola. And see one thing, here the x6 got with 2 points. See, here A, we named that points, and another one is A dash. Okay, here also A and another one is A dash. Okay student, so here the x-axis got with 2 points. So if the graph intersect with 2 points A and A dash, okay, then this 2 point is 2 zeros of the polynomial. Okay, so this one is case 1. Here the x-axis got with 2 points. Okay, let's go for case 2. What is the case 2? See, here see, in this case 2, the x-axis got with only 1 point. You see that? Okay, so in that time A and A dash, that 2 point coincident here. Okay, so in this graph, if the graph got with 1 point, in that time A and A dash coincide. Okay, so here the zeros is only 1 point, that is which one is got the x-axis. This is our case 2. Here only A is the point of this polynomial. Okay students, so this one is case 2. Here only A is the point. A is the point which one got or intersect the x-axis. So here A is our the zeros of this quadratic polynomial. Okay, so third one is case 3. In case 3, see the graph x dash x, this one is x-axis and this one is y-axis. Okay students, so here see, you see this, here the parabola is completely below the x-axis or in completely above the x-axis, completely below the x-axis or completely above the x-axis. Okay, so in that time there are no zero. Here no zeros. Okay, so in 3 cases there are different type of points. In first case there are 2 points, that one is A and A0, which one it intersect the x-axis. So that A and A dash is the zeros of this quadratic polynomial. Here that 2 point is coincident to each other. So here only 1 point is our zeros of this quadratic polynomial, and here the parabola is completely below the axis and another one is completely above the axis. So here the no zeros at all. Okay, so this one is 3 cases for our how we represent the quadratic polynomial by graphically. In this geometrically, we know that here the zeros is 2 distinct points or 2 equal points or no zeros. Okay, so in these 3 cases we know that here the degree is 2, so our points is 2 points. Okay, that 2 points we call that the zeros of this polynomial. Okay, in next class we discuss some problems related to this geometrical zeros of the quadratic polynomial. Okay students.